Hello everyone, welcome back. So now we're going over example 1. Yes, example 1. So what we see here is we have some nice fancy shape. It's got an equation for it. And we want to figure out the centroid location. And their plan is to follow the steps. So I'm going to let you do that. I know you don't have much to go on, so this is one that might be easier just to watch the video. But like always, we have 3 seconds to pause and try it on your own. So 3, 2, 1. And you're back. So hopefully you rocked it. Otherwise, if you had a lot of trouble, we'll work through it together. Okay. So first off, you have to figure out what is your differential element going to be. Like it said, if it's easy to get y in terms of x, then use a vertical element. And so that's what we do. Now we have our vertical element. Okay, yes. We know what its height is because it's always going to be wherever it is along this line. That's going to be its height. Okay, so its height, area of a rectangle is base times height. Its height is going to be equal to x cubed. And what is the width of this rectangle? Its base is going to be dx. Okay? It will be dx. The second thing we figure out is, well, what is the centroid of this? Well, it's obviously going to be right there at the center of this element, and it's going to be half the height. So y squiggly hat is going to be y over 2, while x squiggly hat would be wherever it is positioned. So right here, you can see our dA element. The height is y, which we're just going to substitute in x cubed because that's where, that's the equation for y, times dx, which is the base. And then we know what our x squiggly hat is and our y squiggly hat. So we plug in those equations. X is just going to be right there at the center, which is just x. And y is going to be y over 2, which we plug in our equation will be x cubed over 2. Okay, so x bar is going to be the integral of x squiggly hat dA over the integral of dA. So we have an equation for dA. We have an equation for x squiggly hat. We plug it all in. You can see I've got x to the 4th right here on the top, x cubed on the bottom inside our integrals. And then I take my integration. And I'll get 1/5 over 1/4, which is 0.8 meters. That's for x. What about for y bar? Same exact process. I have an equation for y. I have an equation for dA. Hopefully, when you have like dx and things, everything's going to be in terms of x. So I plug everything in. This is x cubed over 2 because the equation for y is x cubed, and the y squiggly hat is half the height. So y over 2 times x cubed dx, which is dA right here. And then we have dA on the bottom. So just like last time, this will be 1/4. And this is going to be 1/14 times x to the 7th from 0 to 1, which is just going to simply be 1/14. Which, if I solve that, it's 0.2857. Being super honest with you, the integrals are not usually terrible in these kinds of problems. What is terrible is figuring out, is it a vertical or a horizontal element? So remember, if you get y easily, vertical. If you get x by itself easily, horizontal. You just have to choose. And then you follow the same exact steps we saw earlier, where you draw it. If it's vertical, then x squiggly hat is equal to x. Just keep it that way. And y squiggly hat is going to be half of whatever your equation is. If it's horizontal, pretty much the same thing, but just reversed. So don't forget that. Okay, with that, we have our answers. So I will stop here, and next time we'll jump into another example on how to find the centroid of a particular shape. Hope this helped you. See you all later. Bye-bye.